Hallelujah, we've made our way to mixed riders. So in our mixed riders, what we're looking to do here is kind of combine all of our theorems in one and maybe prove some things rather than go find the value of angle A or something like that. So our first thing is to identify 6 other angles, each equal to x. So to do this, it's basically let's just get ourselves into this diagram. And so I'm going to do this. It doesn't say with reasons, but always just think with reasons. So generally it'll be with reasons. So let's have a look. X is over here. And we've got a few things going on the diagram. We've got a tangent over here. So we may or may not use tan chord to go the angle between that tangent and that chord is equal to the angle in the opposite segment. And similarly, we may use, there's another one over here. Oh, well, that would be the same as that. And we could use maybe tan chord again or angles in same sec. So kind of the idea is that you just get into the diagram with these things. There's another tangent and a chord. So there's a tan chord. Those two are equal. And there's the tangent and that chord. There are 2 sides here of a triangle that are equal to each other. So we're probably going to use, isosceles triangle somewhere. There are parallel lines. So here's a line that is parallel to another line. So we may use alternate angles. Well, that looks like that'll be our way into the diagram. So there's some alternate angles. We may at some stage use co-interior. That plus that is 180. We may use corresponding angles. That angle is equal to that angle. We may do a whole lot of things. We're not given a radius or a circumference. We're not going to use angle and semicircle. Well, maybe we'll get to that and show something, but it's not, outright given to us. So let's just go into our values of x. So if that's x, then that's x. We already saw that there was a alternate angles. So I'm just going to fill in along the way and I'll say what the reasons are for each one, but I'm not going to write down each. There's an x over there. Okay. Now, I can see the angles in same seg, and maybe you can, but maybe to get us into seeing that if we can't. So, come on. So, this angle x at D is kind of created or subtended by going backwards here from D to B and C. So if we start from B and C and we go somewhere else on the circumference, so starting from B and C and we go to anywhere else on the circumference, then we're going to see angles in same sec. So that angle across there at A, CAB is also x. So as I say, I'm talking roundabout instead of just going, there it is, there it is. The whole point of this is that you kind of slowly getting into the diagram and going like that and seeing this one and the other one. And I was hoping at that stage you'd be like, hallelujah. So there's something over there. So there's an x. Oh, we talked about this isosceles triangle earlier. So BAC is an isosceles triangle. We've got another angles in same seg to go. That must be equal to that because, and let's just show it as quickly as I can, that from B and A, we can get across to C, so therefore from B and A we can also get across to D, angles in same seg. Now I'm going to stick with that, in fact either of those, and say, well, we've also, it looks like, got a chord to create those, and we've got a tangent, and we know from tan chord that the angle between the tangent and the chord is equal to the angle in the opposite segment. So we seem to have an x over there. No, an x. Oh, that is right. Tangent chord, that means that goes there. Interestingly enough, because we got the second chord over there, that one over there. So that ones over there that I'm talking about are, let's have a look at them here. We've got, say, an x over here because of tan chord. And we could say this is x. And we could say that the reason for this is, whoopsie, let's do it with 3 lines. 1, 2, 3, 1, 2, 3, that FA is equal to FB because of tans from same point. So if you say that that angle over there is equal to that angle there, BAF is equal to ABF, then your reason would be tans from same point. Your reason's not isosceles triangle because you're not given that it's an isosceles triangle. So we've got an x over there, and maybe from tan chord there's another x over there. And I think that may be it, but if you see others, then excellent, well done. As it turns out, look, we've got that, so we could have proven that those two lines are parallel. So it could have been lots of things we could do with our diagram, and I urge you to just keep those things in mind. Don't stop short where the question is. If you see lots more things in the diagram, that's great, because there's normally a whole lot more going on the diagram than is actually asked. Okay, so here we go. We got x. I think we got 1, 2, 3, 4, 5, 6, 7. Said 6. We are overachievers. Okay, so prove that AFB. Now, where's AFB? Let's zoop, doop, doop. AFB, so this angle over there, is equal to ABC. So let's do that one over there, ABC. Well, I mean, to my mind, you've got two triangles, and this one's got kind of angle X and X at the base, so whatever that angle is, and the other triangle's got X and X at the base, so clearly that other angle must be the same, right? They're similar triangles. Not necessarily congruent, could be, but not necessarily. So kind of how we want to word that is maybe, well, I guess we know what those angles are in terms of X. So let's start with this one on the left and say, well, this one here is 180 minus X and X. So that's 180 minus 2X. Reason, sum of angles in triangle. As I said, write down your reasons, but you can hear me rambling through them. And this one over here is 180 minus 2X. Reason, sum of angles in triangle, therefore they're the same. In fact, you could have just said that they're the same because of sum of angles in triangle straight away. F equals ABC. Now, I don't know if the assumption here was that we didn't have one of these x's yet, but we already found one of them. So as long as you got all your statements and reasons going together, then you've got it all. Okay, so that's the first mixed rider. I'm going to hit stop so that you got the second one as a separate video in case you only want one or the other. So what I say to that is, come on.